students, physics, thermoelectricity, class 5, in which we are going to solve some problems. We already solved some problems in the previous class, and even I posted the PDF file or photocopy of the solved problems and unsolved problems from the textbook, and I posted it in a Google Classroom. You download it. So let us see the problem, the fourth problem. The thermoelectric powers for iron lead and copper lead couple are given by P iron is equal to 1734 minus 0.45 T and P copper is equal to 1376 plus 0.85 T. The cold junction being at 0 degree Celsius. Calculate the neutral temperature for copper iron thermocouple. Okay, so we are using here the Tate diagram, theory part, or thermoelectric diagram. Okay, so in which if the two metals are similar there, that is lead and lead in both the thermocouples, so therefore thermoelectric power they given dE by dt at FePb is equal to 1734 minus 0.45 T, and thermoelectric power of copper lead is equal to 1376 plus 0.85 T. Okay, so at temperature T is equal to Tn, that is neutral temperature. They told us to calculate the neutral temperature. So at T is equal to Tn, the copper iron thermocouple thermoelectric power at this point becomes constant, that it is thermoelectric power at the copper iron thermocouple becomes constant. So therefore dE by dt at FePb is equal to dE by dt at CuPb. Okay, so therefore just substitute these two equations and solve for Tn. 1734 minus 0.45 T is equal to Tn is equal to 1376 plus 0.85 Tn. So Tn, here I take this term to right side and this term to left side. So Tn into bracket 0.45 plus 0.85 plus 0.45 is equal to 1734 minus 1376. So therefore Tn is equal to 358 divided by 1.3, that is sum of this is equal to 275.4 degree Celsius. Okay, next problem, that is homework. You solve it, it is similar to this. The thermoelectric powers of silver and iron are 3.34 plus 0.008 T and 16.65 minus 0.03 T respectively. Calculate the neutral temperature for silver iron thermocouple. Okay, you have to follow the same relation here. And let us see the next problem. Sixth problem, the thermoelectric power of cadmium is 3 microvolt per degree Celsius at 0 degree Celsius and 15 microvolt per degree Celsius at 300 degree Celsius. Calculate the values of the constants A and B. Okay, so therefore thermoelectric power of cadmium 3 microvolt per degree Celsius at T is equal to 0 degree Celsius. So therefore we know the equation of EMF E is equal to AT plus BT square, where A and B are the Seebeck constants we have to find. So differentiate this with respect to T, dE by dt is equal to A plus 2BT. So at T is equal to 0, 3 microvolt per degree Celsius is thermoelectric power. Just substitute here 3 microvolt per degree Celsius is equal to A plus 2B into T. T is equal to 0. Substitute here. So you get A is equal to 3 microvolt per degree Celsius. Clear? Then we solve it for B. So cadmium, that is thermoelectric power of cadmium, is 15 microvolt per degree Celsius at T is equal to 300 degrees Celsius. So therefore E is equal to AT plus BT square. dE by dt is equal to A plus 2BT. So now at T is equal to 300 degrees Celsius, they given thermoelectric power dE by dt is equal to 15 microvolt per degree Celsius. Just substitute here. So this is equal to 3 plus 2B into 300. 300 into 2, 600 B anta kati. So that it is equal to, this is 15 microvolt per degree Celsius, this is 3 microvolt per degree Celsius minus it. So you will get 12 microvolt per degree Celsius divided by 600 degrees Celsius. Clear? So this is equal to 0.02 microvolt per degree Celsius square. Okay. Now another homework. For thermocouple of copper nickel, the junctions are at 0 degree Celsius and 100 degree Celsius. Wait a minute. 0 degree Celsius and 100 degree Celsius. Calculate thermoelectric power, neutral temperature and temperature of inversion. Okay, you have to find this thing. Then last problem of this chapter. So they don't give you this graph diagram in this problem. They just given the problem here. Just read it. The thermoelectric power of iron is 15.5 microvolt per degree Celsius at 20 degree Celsius and 4 microvolt per degree Celsius at 100 degree Celsius. Clear? The thermoelectric power of cadmium is 5 microvolt per degree Celsius at 20 degree Celsius and 13 microvolt per degree Celsius at 100 degree Celsius. Calculate total EMF produced by cadmium iron thermocouple. So you have to draw this graph. So first observe the values. Clear? Which one is greater? 15 microvolt per degree Celsius at 20 degree, in the sense this side dE by dt, in this direction temperature we represent. So first observe this equation. 15 is at 20 degree, so this thing here it comes, and 4 at 100 degree, in the sense at higher temperature thermoelectric power is decreasing. So therefore that is for which metal? Iron metal. So I draw this line like this for iron metal. Okay, and I represented at T is equal to 20 degree Celsius 15 microvolt and 100 degree Celsius 4 microvolt. Clear? Now then the thermoelectric power of cadmium is 5 microvolt per degree Celsius at 20 degree, in the sense its value is lower at lower temperature, and 13 microvolt per degree Celsius at 100 degree Celsius, in the sense higher at higher temperature for cadmium. So I draw the line. So here it is, this is for cadmium, and at 20 degree it is 5 only. Clear? And for 100 degree Celsius it is 13 microvolt. It is here. Okay, so it is an approximation graph. Okay, so now we have to find the total EMF for cadmium iron thermocouple. So this is also from the theory of state diagram or thermoelectric diagram. So total EMF is equal to area ABCD. A, B, C, D we have to find. So that is the area of trapezium. So that can be found by, it is equal to 1 by 2 AD into BC. AD into BC into height, that is this EF height. Okay. So therefore 1 by 2 AD is AD. Dear students, from this point, that is from the x-axis point, it is 15.5. So therefore AD can be found by 15.5 minus 5. Then only we get AD, that it is equal to 10.5 plus. Now BC. So we have to find BC here. So BC is equal to 13 minus 4. Clear? So that it is equal to 9. Clear? Into height, that is this height. So here it is the temperature difference. We can take 100 minus 20. This height is equal to 80. So solve it. Simple problem. You will get 780 microvolt. Okay. So here completes thermoelectricity chapter and also problems on the thermoelectricity chapter. So solve some other unsolved problems, even homework problems that I have given. okay, and go through these solved problems also. I posted in a Google Classroom. Okay, so thank you. Stay home, stay safe.